In this video, I would like to show you how to find a general solution using separation of variable. I have two differential equations for you. The first one is 5 plus x times y prime equals to 7y. The first step is you change the y prime to dy dx. So we have 5 plus x and then parenthesis dy over dx equals to 7y. The next step is I would like to move the dx to the other side. So you have 5 plus x and then times dy equals to 7y times dx. And then the dy is on the left hand side. Let's divide both sides by 7y. So we have 5 plus x divided by 7y and then dy equals to dx. And then you multiply both sides by, actually you divide both sides by 5 plus x. So you have 1 over 7y dy equals to 1 divided by 5x, actually 5 plus x dx. So this step is called the separation of variables. So finally we have all the y on one side and then we have all the x on one side, and then the y is attached to dy and then the x is attached to dx. So these three lines we call them separation of variables. So these three lines we call this separation of variables. And then to make my next step more convenient, I would like to multiply 7 on both sides. So when I do integration, the left hand side is just ln absolute value of y. So we have 7 divided by 5 plus x dx. Okay, so now you integrate both sides. So integral, and then the integral of 1 over y dy is absolute ln absolute value of y. Don't worry about the plus c, we stick the plus c to the x side. And then what about the other side? The other side you can take that as 7 and then integral 1 divided by 5 plus x dx. You can try a u substitution if you want to, but at this point I assume that you can integrate without using a u substitution, because this is a very simple u substitution. You can let u equals to 5 plus x, but this one is just after you integrate, you have the integral of 1 over u du, so you have ln absolute value of u. So the next step is ln absolute value of y equals to 7 times ln absolute value of u, right? So you put the 5 plus x in there and then you add a c to it. So it looks like the integration is finished, but in differential equation, you have a couple more steps that you have to do, and you have never seen those steps in the past. So the first step that you would like to do is you would like to rewrite the constant c. Yes, this is new in differential equation. So the left hand side, we do not touch that right now, and then the 7 ln 5 plus x. So since we have an ln right there, so again, listen to me right now. A constant is a constant. It doesn't matter how you state the constant. So a constant c is the same as ln constant c. Can you just write this down? A constant is a constant. So actually, I should write it down for you. So a constant is a constant. So it doesn't matter how you state the constant. So doesn't matter how you, actually I should write how you express the constant. So we can have c and then equals to ln c, all right? And then you can say that is equals to 7 ln c. Again, a constant is a constant. Ln constant equals to a number that is a constant. 7 times ln constant is just a constant. So it doesn't matter how you express this constant. So I am going to jump over there. So ln absolute value of y equals to 7 ln absolute value of 5 plus x, and then plus, look, 7 ln constant. And then I will factor out the constant. So factor out the constant. So you have ln 5 plus x and then plus ln constant. Oh, square bracket. And then here is one thing that you have to review for the properties of Ln. So if you have Ln A plus Ln B, that is equals to Ln A times B. So you can try this real quick. Ln phi plus Ln 10, that is equals to Ln phi times 10. So this is Ln absolute value of y equals to 7, and then we multiply the c and the phi plus x. So we have Ln absolute value phi plus x, and then we multiply the constant c. And then the next step that you will have to do is, so I'm going to review this formula for you. So let's say you have n times Ln A, so that is equals to Ln A raised to the nth power. So if you have 2 times Ln x, that is equals to Ln x squared. If you have 2 Ln phi, that is equals to Ln and then phi squared. You square the phi first, and then you take the Ln of the product. So what else do we need to do? Just bring the 7 up. So we bring the 7 up. So we have Ln absolute value of y equals to Ln, and then we have phi plus x times a constant, and then you raise that to the 7th power. And then one last properties for Ln is if you have Ln A equals to Ln B, that means A is equals to B. So if you have Ln 2 equals to Ln 2, then you can say 2 is equals to 2. So this is called, I think this is called the 1-to-1 property. So this is called the 1-to-1. And then this is called the, I think the plus, they call that the sum rule or something. And then there is power rule. So sum rule, difference rule, power rule for the exponent. So now you have this equals to that, so you can say that the absolute value of y is equals to parenthesis 7th power absolute value phi plus x and then times c. So this is your final answer. So this is your final answer. All right, so we still have one more problem to go, so let's take a look at that. So we go all the way up, and then we have a yellow one right there. So y times y prime equals to 10 times sine of x. So we have y times dy dx equals to 10 times sine of x. So first of all, what should I do? This one is easy. Just multiply the dx to the other side. So y dy is equals to 10 times sine of x dx, and then you can just integrate, right? So you can integrate because the separation of variable is done. So the integral of y is just 1 over 2 y squared, right? And then the sine of x, the integral of sine is equals to negative cosine. So negative cosine, and then you put the 10 in front of the negative, and then you add c to it, and then you can multiply both sides by 2. So y squared equals to 2 times negative 10 cosine x plus c, and then y squared is equals to negative 20 cosine x, and then plus 2c, right? And then once again, in differential equation, a constant is constant. A constant is just a constant. So we can do y squared equals to negative 20 and then cosine x. 2c is just a one big constant. That's it. So this is the final answer of the second differential equation. And what is this called? This is called a general solution. Why do we call this a general solution? Because we don't know what the constant c is. How do you find the constant c? You have to give me an initial value. You have to tell me what x equals to, what y equals to, plug in the x, plug in the y, solve for c. So after you solve for c, then that is called a particular solution. Alright, so that is the end of this video. If you think my instruction is clear and helpful, give me a like, share the video for me, subscribe to my channel. If you're on your way out, I will catch you all in the next lesson.